Okay, now what we have on the board is how to solve that system of linear equation using the inverse matrix method. So we're going to look at, first of all, bring out the matrix and set it in this form. Bring out the system, set the system in the form x. Okay, let's see what we're going to do here. The coefficient is 1, minus 2, and 1. Here we have 2, minus 3, and 2. Here we have 4, 1, and what? 8. This is the matrix. If we multiply this matrix by x, y, z, the column vector, we are going to obtain the column vector 4, 7, 19. This is what we obtain. So to find x and y, to find x, y, z, we need to multiply from the left-hand side the inverse. Let's A be the matrix 1, 2, 4, minus 2, minus 3, 1, 1, 2, and 8. If we multiply this equation from the left by inverse of A, this is our A. If I multiply A from this side by its inverse, I'm going to have the inverse of A times from the left, we'll also multiply this one. So if I multiply from here, the left, the inverse, I also use the inverse to multiply this one from the left. Now what is going to happen? A inverse times A will give us the unit matrix. So that one goes out and we have x, y, z is equal to A inverse times 4, 7, 19. So this is the equation we now need to solve. We are left to solve this equation. So what is the most important thing in this equation is to find the inverse of what? A. Now, a matrix is said to be invertible if its determinant is not equal to what? 0. So to find A inverse, we need to get the adjoint of A all over determinant of A. So determinant must not be 0. If it is 0, this fraction will not what? Hold any value. So let's quickly look at the determinant. Determinant of A, that A is, remember from our previous work, when we looked at the determinant of this matrix, we got 4. If you can remember, the determinant plus, minus, plus, we have 1 bracket, minus 24 minus 2, okay? Minus minus is plus, and you have 2 there. Now, this time this is 16 minus 8, okay? Remember how we did our determinants in our previous work? That's what we're doing right now. And the last one is plus 1 in bracket 2 plus 12. That will give us 4. If we evaluate, we have minus 26 plus 16 plus 14, which is minus 26 plus 30, and that is what? 4. So the determinant of the matrix is not equal to 0. Next is to get the adjoint of A. Next is obtain adjoint of A. Now, how do we do that? This we have to pass through processes. First of all, we must get the minor of A. Work with me. Let's see how we obtain this. This is our A. Now let's go. The minor of A, let's get the minor of 1. The minor of 1 is the determinant of this matrix. When you eliminate minus 1 and 2, which are on the same row with 1, and the one on the same column, whatever that is left, take the determinant, which is this times this, is minus 24 minus 2 is minus 26. Write it in place of 1. Now, the minor of minus 2 is 2 times 8, which is 16, minus 4 times 2, which is 8, and that is 8. So the minor of minus 2 is 16 minus 8. The minor of 1 is 2 plus 12, which is 14. The minor of 2 is eliminating this and this. We have minus 16 minus 1. Minus 16 minus 1 is minus 17. Okay? The minor of minus 3 is 8 minus 4. Let's take it again. The minor of minus 3 is 1 times 8 minus 4, which is 4. Okay, the minor of 2, eliminate this and eliminate this. You have 1 plus 8, which is 9. The minor of 4 is this one here. Minus 4 plus 3 is minus 1. Okay, let's take it again. The minor of 4 is minus 4 plus 3, which is minus 1. The minor of 1 is 2 minus 2, which is 0. The minor of 8 is this one here. Minus 3 plus 4, which is 1. This is a minor matrix of what? The cofactor of A is gotten by applying this matrix, this signs, plus minus plus, minus plus minus, plus minus plus. Apply it on the minor. So we have plus 26 for the cofactor. Sorry, minus plus minus is minus. Minus plus is minus 8. You have plus 14. Then minus minus 17 is 17. You have 4. Minus 9. And then plus minus 1 is minus 1. You have 0 and you have 1. So this is the cofactor matrix. Next in line is the adjoint of A. The adjoint of A is equal to the transpose of cofactor matrix. So the transpose is to let the rows become the column. We have minus 26, minus 8, 14, 17, 4, minus 9, minus 1, 0, 1. This is the what? Adjoint of A. Now, next is to find the what? Put into this formula. We have the adjoint of A and we have the determinant of A. So if we slot into this formula, we have the inverse of A becomes the adjoint of A, which is minus 26 divided by the determinant. So each entry will be divided by 4. Okay, divided by 4. 17 divided by 4. Minus 1 divided by 4. Okay. Now here we have minus 8 divided by 4, which is minus 2. 4 divided by 4 is 1. 0 divided by 4 is 0. 14 divided by 4. Minus 9 divided by 4. And 1 divided by 4. This is the inverse. The inverse of what? A. Now we go ahead to solve this problem x, y, z, which is equals to A inverse times the matrix here, which is 4, 7, 19. This is the original equation. Now, we remember the original equation is this. This is what led us to start looking for A inverse. Now that we have A inverse, we quickly put it in there. We have x, y, z is equal to A inverse is minus 26 over 4, 17 over 4, minus 1 over 4, minus 2, 1, 0, 14 over 4, minus 9 over 4, 1 over 4, into 4, 7, 19. So we multiply, our x becomes multiply minus 26 over 4 times 4 plus 17. We use the column vector to multiply the row to get our x. 17 over 4 times 7 minus 1 over 4 times 19 over 1. This will reduce to, let's quickly solve. We have 4 divided 4 is minus 20. Okay, let's have 26 times 4 is minus 104 over 4 plus 17 times 7. 17 times 7 is 119 over 4 minus 19 over 4. Okay, the whole thing, LCM is 4. We have 119 minus 104 minus 19 will give us 104 plus 19 is equals to this minus 119 will give us 4. So we are looking at minus 4 over 4, which is minus 1. Therefore, x is minus 1. So what is our y? Multiply the column vector, the same column vector again with this row. You have minus 8 plus 7 plus 0 will give us minus 1. Y is also minus 1. And then let's quickly get our z. Okay, so we now go ahead to find our z. Our z is gotten by multiplying this column vector with this one to get your z. That will give you 14 times 4 over 4, okay, minus 9 times 7 all over 4, okay, plus 19 all over 4. I got that by multiplying 14 times 4 over 4 minus 9 times 7 over 4 plus 1 times 19, which is 19 over 4. And when we solve that, 4 times 4 is 16. You take 1. This time this is 56 over 4 minus 63 over 4 plus 19 over 4. When we solve, we have 56 plus 19. 56 plus 19 is going to give us 5. You have 7. You have 75 minus 63. And that is going to give us what? 75 minus 63 will give us 12, if I'm correct. Yeah, 12 all over 4. And the answer is what? 3. Therefore, from there we have our x is equals to minus 1. Our y is equals to minus 1. Our z is equals to 3. This is the same result we got in our previous work when we used the Cramer's rule to solve exactly the same system of equation.